Today we're talking about concrete. How do you design durable concrete? What makes a good mix design? And what do you need to think about when you're operating a building? So there's a couple different ways to think about concrete. They can be cast in place, they can be precast off-site and brought to the job site, but they all kind of function a similar way. You might also have beams or columns that are integrated into that concrete, but all of these operate in a similar fashion. They're called a mass wall moisture management strategy. And the idea behind that is some water can get in and absorb and it dries back out, and you've got enough mass behind it that moisture doesn't leak or come to the inside of the building. That's generally the principle that we call it, a mass wall, mass storage assembly. Now they're a relatively cheap and robust way of building. They may be sliding panels, they may be shear panels, they may be structural, and there's a whole bunch of things to consider when you're looking at concrete buildings. Now, the type of concrete mix actually has a huge impact on the absorption rate, on the cracking potential, and ultimately on the robustness of these panels. So we'll go into that a little bit. The durability of concrete panels is primarily driven by the reinforcing steel inside the concrete. This is set into the concrete to give it tensile strength and to hold the concrete together. The main problem with reinforcing steel is it corrodes. Now, the concrete itself has a protective mechanism, and the alkalinity is going to protect the reinforcing steel from this corrosion. And that's a process called carbonation. It's a CO2 plus water plus calcium hydroxide. Those three elements come together to reduce that alkalinity over time. Now, you may hear people in the concrete industry talk about concrete absorbing CO2, and that is true. It will absorb very, very minor amounts, nowhere near the amount of CO2 it takes to produce it. Now, if you have a crack in the concrete, the water is going to enter into that crack, and it's going to start to locally create those carbonation cycles inside the crack. So it's going to accelerate that carbonation process and accelerate the corrosion of the reinforcing steel. If that reinforcing steel corrodes so much, it'll actually pop off the outside of the concrete, and that's a phenomenon called spalling. You may add some admixes into concrete, which can help control that cracking, and some of them can actually create some healing effects, so those cracks don't propagate or grow larger. That's one way to look at some of the concrete mixes. The other thing you can do is look at some penetrating sealers, some silanes, siloxanes. These kind of bridge into some of the, they don't bridge the cracks, but they fill some of the micro pores, so it'll reduce the absorption rate into the concrete and slow that carbonation rate down. The other thing that's probably one of the best things for concrete longevity is a paint coating. An elastomeric paint coating can bridge cracks, and you can renew that over time many, many times. So if you do get some breakdown, some deterioration, you can go back and recoat that and bring it basically back to brand new. Now, when we're talking about concrete walls, we have to consider condensation. Because concrete in cold climates, the concrete is going to be a cold surface, and any of the interior moist air reaching that condensation, that concrete, is going to result in some condensation. The modeling method you might look at is something like ASHRAE 160. That puts in all the variables of the wall, of the climate inside and outside, and runs through a kind of a pretend climate cycle or year or a number of years if you want. When you look at most concrete wall assemblies, those will pass the ASHRAE 160 criteria. And that's mostly because of the material sensitivity to mold growth. If you have materials in your walls that are inert or don't support mold growth, you won't see any mold growth. But you do get condensation. And so if you have organic materials in that wall, and you have condensation, you're likely to get fungal growth. If your assumption is that everything in your wall is non-organic and unlikely to support mold growth, you have to consider cross-contamination during construction. Are you likely to get dust on the insulation, on the studs, on the concrete during construction? Most likely. So even though your model might say that you're not going to get fungal growth, you need to consider cross-contamination and whether those surfaces actually will support mold growth. If you are not looking for mold inside your walls, you've had no reason to open your walls up, you probably wouldn't see this fungal growth. But you might smell it. You might smell a musty smell or a bit of a stale air smell. That's inside the walls and kind of coming through. So if you're looking at a prospective house or your own apartment, and you sort of smell something like a damp basement, that may actually be hidden in behind the walls, which you can't see. To prevent, or one of the ways to design a wall, a concrete wall, to manage this condensation is with a rigid insulation board that's going to act as an air and vapor barrier, preventing all that warm, moist air from reaching the cold concrete surfaces, and you won't get that fungal growth. In some climates, ventilating your apartment is going to reduce the risk of condensation, but it's not going to eliminate it completely. So just something to be aware of, that it is climate dependent. Some cold climates, some humid climates, it's going to have those sorts of problems, which you need to have a close look at. When we get to joints and details around precast, we incorporate what's called a rain screen design. That's got 2 layers of defense. It's got an inner defense layer, which is an airtight inner barrier, and an outside barrier which deflects it. It's sort of like a raincoat on the inside and an umbrella. The umbrella is going to deflect a lot of the water, and then you've got a raincoat in case some of the extra stuff gets between. And then the key part is between those 2 layers having a drainage mechanism. So that outer layer, if it leaks a bit of water, that's going to be okay. It can drain out and dry later on. When you transition a precast to a window or to another assembly, you're going to maintain that same dual seal approach. So the air barrier from those assemblies and those windows seals to your inner, and you have an outer barrier as well. Key kind of premise to carry through all your joints and details. Maintenance on concrete is really underappreciated, how much work concrete can take to keep it to reach its full life cycle. We talked before about some of the cracks in concrete and how that can accelerate a carbonation cell or a corrosion cell on the reinforcing. So you really need to pay attention to those cracks and maintain them as you go. Now, if you've got a paint coating, relatively easy to grind out that crack, seal it, and paint back over. You can blend it in really well. If you've got an uncoated concrete or you've got a stained concrete, it can be very hard to make those look good, and in fact, they look quite terrible in most cases. So something to be aware of, if you've got a really aesthetically demanding precast panel or concrete panel, how is that going to be maintained and what happens when it does crack and you need to repair it? So a few key takeaways. There are some things to consider in concrete when you're designing these panels and these buildings. It's not just one size fits all. There are a lot of variables that you can change and update, and considering how the building is going to be maintained and operated is a key function in that design process. You can manage condensation with an exterior insulation, or more likely you're going to have a rigid internal insulation which controls that condensation. At those details, between panels or with adjacents, maintain 2 seals. The inner one's your air barrier, your outside one's that rain screen. And the ongoing maintenance, you need to keep doing that to keep protecting the steel. So it's not like you can just build this building and forget about it. There is a maintenance requirement with precast, which often goes underlooked or underappreciated.